G'day, Pete Coman here, and beside me, as always, my good buddy and friend and mentor, maybe not mentor,
Just a
peer,
Protege?
protege possibly.
all-round great guy.
All-round great guy, gay guy, great guy. Whatever takes your fancy. Mark, the bearded tech skiing. Welcome, Mark.
Crowd goes wild.
And we're at...
The ladies throwing the roses.
Yeah, no. As long as it's roses and not their underwear. And we're at ISE 2020 in Amsterdam, and we're joined by a very, very special guest, Mr. Justin. How do you pronounce your last name again?
Kennington.
Kennington. That's it, Kennington. Yes.
Head guru,
From?
SDVoE.
I'm with the SDVoE Alliance.
Welcome to the Tech Effect.
Well, thank you. It's a pleasure to be here so far.
So far. Yeah, just wait till we
See where this
finish.
goes.
There's no guarantees. We never signed a waiver.
That's exactly right. And why are we here, Mark?
We're here because we're trying our best to unpack AV over IP. And so, first thing I wanted to really get in and ask you, Justin, was talking about matrix. I was just watching your presentation on matrix switches, and I noticed in your presentation you were doing some cost comparisons at about 8x8. It was still cost comparative, or perhaps even, I'll get that word out in a minute, but perhaps even cheaper than running an 8x8 matrix.
Sure.
How is that? So that data, is that recent? Because when I was sort of looking at this maybe 2 years ago, it was about the sweet spot of about 16 by 16.
Yeah, I think that what you're talking about is the crossover point, right?
Yeah.
We all understand a 1,000 port system, you could have huge savings with AV over IP. Meanwhile, for a point-to-point extender, the other end, a cheap HD-based extender is going to beat a pair of AV over IP devices talking to one another.
Yeah.
So where is that crossover point? And yeah, I think these days, depending on the matrix switch, it is probably in the 10 to 12 port region where that crossover exists. So we've got a demo at the booth around the other side, comparing a 4x4 matrix to a 4x4 SDVoE system. And that comparison is all about performance and feeling it for yourself. But the rough cost of those two systems at list prices is $18,000 for the matrix and about $12,000 for the SDVoE rig. Yeah. Now, keeping in mind that's a Crestron digital media rig, right? Matrix switches don't really get more expensive than that. And if you're really just building a 4x4, maybe you're going much, much lower end. And I'm not going to say that I'm much cheaper than a low end kind of knockoff 4x4 matrix switch. But in the sort of mid commercial grade and up range, that crossover point's in the 10 to 12, maybe 16 ports.
Yeah, absolutely.
And so why SDVoE? I mean, there's so many flavors of AV over IP out there, and there doesn't seem to be a standard, right? So why SDVoE?
Well, I sort of disagree. I think SDVoE has become something of a standard.
No, you know what I mean? Like when I use the term standard, I'm talking about a ratified standard.
Sure.
You know,
and that's a fair distinction.
Not a pseudo standard.
And that's a fair distinction, but the problem is with the real standards, right? And people are working on those, right? SMPTE's got 2110 with AIM stacked on top of that, and AMWA stacked on top of that, and whatever this new thing, MPX, NTX, I don't remember, whatever their new thing is. It's like, the problem with those kind of standards bodies is they sit around thinking about how to make a perfect system. And now here we are 10 years later since SMPTE 2110 started, and show me the product. Where's the product I can go buy? It doesn't exist. So what we've done is taken that opposite approach. Like, let's just build something that works, build something that can be interoperable, and let people adopt it, and let that be the standard.
So it's kind of like what Valence did with HD-based T, and
a little. I would draw the comparison actually more to Audinate and Dante.
Okay.
Right, and those guys honestly, Audinate's a member of our alliance, but I have a ton of respect for what they've done, and frankly modeled a lot of our ideas around them. They're not based on some IEEE standard, right? They invented a really good technology that works, and they got it out there. And now there's like 2,000 Dante products, right? How is that not a standard?
Yeah, well, it's pseudo standard. It's an industry standard,
I understand.
but not a ratified standard.
But practically, I'm saying.
No, I agree. I totally agree. So why, like, when there are standards out there that are readily available, like for example AVB, why do you think that hasn't been taken up it's a standard that's available. Anyone and everyone can use it, but we've really only got one manufacturer that's using that
For video.
For video.
Well, the practical answer is that these standards aren't complete. Right? AVB is a set of standards, IEEE standards, that solve a couple of important and necessary problems. Right? It's about how do you move a synchronous video signal across a potentially asynchronous network, right? And AVB solves that with IEEE 1588. We say, well, we won't. We'll synchronize the network. There's your problem solved. And then they think about how do I manage bandwidth where there might be limitations, right? And they use another IEEE spec to get around that. So that's great. Those are two problems that we have to solve. SDVoE has our own solutions to those problems, but it doesn't say things. For example, AVB doesn't specify a codec. Right. So you could go build a certified AVB device with an MJPEG encoder. I can go build a certified AVB device with an H.264 decoder. And I'll be getting your bits at exactly the right time, exactly every time. I won't have any idea what the hell you're talking about. But so it's incomplete. So even the folks who implement it have to then add on their own parts and pieces, and now his isn't compatible with his.
Gotcha. Okay.
Justin, you were mentioning Ordinate and Dante. It intrigues me that they're a member of SDVoE, but do you see a threat from them with their video product?
Well, that's a delicate question, because if I say yes, I'm copping to being worried about something. If I say no, I'm being kind of a jerk to a member. I think that SDVoE already has an awful lot of market traction, with 50 adopters of the standard, with 200 products available and shipping now. And no other standard, pseudo-standard, or approach to AV over IP can say that.
Very diplomatic, well handled.
And there's a lot of talk in the industry. We've got two solutions. We've got 1 gig solutions, 10 gig solutions. What's your take on that? Like, why is one better than the other?
I think frankly the 10G, 1G debate is a distraction designed to keep people buying matrix switches.
Right. Okay.
That's what I think. I think you can spend too much time worried about 10 gig versus 1 gig, and sort of miss the real show, which is that a technology like SDVoE can actually fully replace the matrix switch. There is literally nothing a matrix switch can do that SDVoE cannot do, and that's not true of any other AV over IP approach. Right?
But surely, if you've got a 10 gig pipe, you can do more with it, right? Whether that's less compression or maybe multiple streams, right?
Yeah, but what about scalability there? Like, we had that conversation yesterday. What's the scalability at SDVoE?
Sure.
So if you had 20 or 30 sources.
Well, first of all, I can go buy a 48 port 10 gig switch for like $4,000. So if 20 or 30 sources is all you're worried about, no problem. Netgear has just recently announced, and they've got it here at our show. I'm looking over this way because I see it. They've just announced a line of their managed switches that includes 100 gigabit connectivity. They've got a 100 gigabit times 32 switch over there. And now the idea is you hang several 10 gig switches over there off of that. And their product director, Laurent Mazier, gave a talk on our stage here called How to Design a 640 port System in 15 Minutes. Wow. And that's what they're talking about. So the Netgear's own solution very easily scales with their stacking technology. Just plug in some cables and tell it who's master. And now you've got a 640 port non-blocking 10 gig network.
And I think to put things into perspective, from a cable infrastructure point of view, from what I hear, the resistance towards 10 gig solutions is, oh look, not many people have the infrastructure for it and so on. And like Justin just pointed out, I mean, it's not that, it doesn't cost that much to actually put that, the active side in place. And you think about it, when we talk to clients about cabling infrastructure, we've got to remember that Cat 6 was ratified in 2002, I believe. So, you're talking about a technology, a standard that's 17, 18 years old, right? Why are we still talking about a 1 gig infrastructure solution? Surely the standard is, a minimum standard is Cat 6A, which is supporting 10 gig. And we should be putting in the active equipment to support that.
Right. But is that a reality? Maybe in some corporate environment, but certainly in my space in education, Cat 6A is definitely not. It's just standard old Cat 6, and there's just some fibre links between switches. It just doesn't seem a reality in the world that certainly I operate, and it's private school.
Sure.
It's K-12 private.
You said that what? You said Cat 6 is your standard?
That's the standard. It's not ours as far as the school goes, though.
Yeah.
They're deploying Cat 6.
Right. Okay.
But that's the thing. So someone's not doing their job, really.
On the one hand, I would suggest Cat 6A. On the other hand, 10G base T does support Cat 6 runs. There's a shorter distance, 55 meters.
Yeah.
So that could be a challenge still. But there is some support for Cat 6 officially by IEEE spec.
But the reality is, fiber's certainly going to be the way of the future.
I disagree with that. I don't think so. I think the benefits of PoE far outweigh anything that fibre can deliver. Yeah, I mean, you're delivering anything up to basically 100 watts over a cable where you can power devices remotely. I mean, for me, that's a godsend. Yeah.
I think people, including myself, as before I learned this lesson, have been predicting the rise of fiber and the death of copper cable for an awfully long time. But
It still hasn't happened.
turns out there's some very smart people with a lot of vested interest in keeping copper alive.
Yeah.
And so I quit betting against them.
Yep.
So, compression. The conversation I had yesterday that SDVoE can't even say that they're now uncompressed 4K because it's only 10 gig.
Well, careful. Yeah, we've never been shy about that. SDVoE's, let's say, philosophy is use as little compression as you need, right? So when we're sending a 1080p signal, that's 3 gigs. We don't touch it.
Yeah.
4K 30, 6 gigs.
Yeah.
We don't touch it. You're right, 4K 60 is 12 gigs of data.
Yeah.
Now I might need to put a pin in that and talk about 12 versus 18. I'll come back. But yeah, we're all smart guys here. We can see that 12 gigs doesn't fit in 10 gigs.
Yeah, that's
Right? Even my engineers back at home figured that out.
Yeah. So
in that mode, when the data is 12 gigs, we do have our own compression engine that turns on. But what it doesn't do is squeeze it by 20 to 1 or 100 to 1. We squeeze it from 12 gigs down to 9, right? Like 1.3 to 1. This compression for any normal kind of video signal is actually lossless, right? Like a zip file on your computer. You never lose data. Sometimes you can compress it a lot, sometimes you can compress it a little, but you never ever lose data. That's sort of how SDVoE's compression looks. Now there are cases, what's called high entropy content, where our codec falls from mathematically lossless to visually lossless. That content is snow, right? So meanwhile, visually lossless snow, like you can't see anything anyway. So that's the point, is that even though we're compressing for any normal signal, whether it's graphics, images, PowerPoint, computer desktops, any practical application will actually be mathematically lossless.
But the reality of it is, how much 4K content are you really consuming or pushing around anyway? I mean, sure, there's certain use cases and applications, but they're fairly few and far between.
Yeah, it's an interesting subject, really. You walk over into the LED stand there and Layout have got their 8K 0.6, and you're going, over here there's 8K displays, and that's what's happening, that development, but then we've still got to get infrastructure that can support it, and then we've got to get content. It doesn't seem like we've really got 4K nailed yet. So what happens, and the interesting question around it for you is, where is SDVoE seeing 8K, and what are they preparing for?
Well, look, I don't have much to reveal at this show, but I can assure you this isn't the first time we thought about it. Yeah, but who's that guy? So 8K is something certainly on our roadmap. I suspect that the next time we meet, we'll have a lot more clarity to share. Keep in mind that SDVoE technology is mostly driven by one of our founding members, Semtech, who builds the chips that that go inside these boxes that make them perform SDVoE. So it's Semtech's roadmap that's going to help drive SDVoE to how and when we get to 8K. But Semtech just finished up and just released a new dedicated ASIC chip that's no longer the more power-hungry and more expensive programmable chip that SDVoE has been based on. And so that new ASIC chip is going to help drive down costs, drive up adoption, and maybe most importantly, get us into even more places because of the power consumption. Right today, a 1-gang wall plate with SDVoE, it can't be done, period. But with this new ASIC, that sort of thing becomes possible. So what are the other new form factors that become possible? Anyway, I've gotten off track, but it's their roadmap that's going to drive 8K, and I think in the coming months there will be more to talk about and explain there.
And what HDMI and DisplayPort standards are you currently supporting, and what's the roadmap?
Oh, so today it's everything up to HDMI 2.0A, and of course the next plan will be about HDMI 2.1 and all the 8K formats that it supports.
Okay. Yep.
Bandwidth deal there, isn't there?
There's really interesting questions that come up there, right? Because now we're talking about a raw signal up to 48 gigs.
Yes. Yeah.
So, we have a couple of choices, right? You can stay at 10 gigs and squeeze that 5 to 1. You could increase your bandwidth and go to like a 25 gig pipe.
Yep.
You're still increasing our compression to 2 to 1. The question there is, we spent enough time with this 10G, 1G BS. Like if we start trying to insist on 25G, like we're having this problem all over again.
Sure. And do you have, because you've got a 10 gig pipe, do you have any plans to do multiple streams, simultaneous streams? So like maybe up and down at the same time?
In fact, I mentioned that ASIC from Semtech, it comes in a few flavors for manufacturers to buy this one or that one for their product.
Yeah.
One of those flavors actually includes a bidirectional capability. So here's a single chip that can ingest content out to HDMI while taking the HDMI content and putting it back onto the network at the same time. So there's interesting sort of areas around collaboration, around image processing, that's going to be really useful.
And I think like for me in education, like there's manufacturers out there that have a transceiver, but it's not a true transceiver. It's a transmitter or a receiver.
Flip a
right?
switch
It's
and it's
one or
this.
the other.
Flip a switch and it's that.
But for me, having like if you're doing pods and things like that in a class sort of situation, and you want to push and pull content constantly, and like with most solutions, you need 2 boxes, a transmitter and a receiver to do that at each end.
Yeah. And the cost just blows out.
Correct. And more. You got more boxes, more cabling, more switch ports, more. So why not utilize that one cable, utilize the pipe, and to do that?
Well, in fact, remember Ethernet is fully bidirectional.
Correct.
So if you got 10 gigs going this way, you're wasting the 10 gigs that's not going the other way.
Correct. Yeah.
So I would expect. I mean, that chip was just announced in November. Of course, some manufacturers had access to it a little before that, but certainly by the time we're setting your next ISE, I think you'll be able to buy products like that.
Okay.
By Infocom, I hope you'll see announcements of them.
Nice.
Right.
Sounds good.
All right, excellent. And so, little free plug for SDVoE. Anything special you want to tell us?
I think that the best thing.
Hey, what's free? Do you say free plug?
Free plug.
Well, the rest. I'm sure the rest of the interview has a cost associated, but this part is free.
All right. Okay.
The best thing we have going is our SDVoE Academy, right? What you see here on our stage at this booth is sort of the live manifestation of that. But the SDVoE Academy is our free online training resource that's designed to. We're not going to turn any AV guys into Cisco certified engineers. That's not our job. Cisco can handle that. But we want to educate them up to a level where they can have the conversation with the IT team, where they can be more confident in discussing that, in interfacing with those guys, and in explaining, here's this thing I want to put on your network. How do you talk to an IT guy about what it is and what it's going to do to his network so that he can then, manage it and deal with it? So the SDVoE Academy, today we have 50 courses posted on AV topics, on IT topics, and of course on SDVoE topics. But some of them are just generic, that have nothing to do with us. And we put out one new course every week.
Okay. And is there credits about for
some
like
of our
Mixer?
we do have one of the let's say a piece of core curriculum we have is called SDVoE Certified Design Partner. Right. The idea of this curriculum is to say, let's assume that you know how to design matrix switches. You've probably been doing it for years. Here we're going to teach you what are the new considerations, what are the new capabilities, and what are the new limitations of designing in an SDVoE system. And then at the end of that, you get certified, you get a nice certificate with my signature on it, suitable for framing.
Your signature?
That's right,
oh, wow.
Suitable for framing. And that course does come with renewal units.
Nice, very good. All right.
Nice. Justin, thanks so much for joining us.
Great to be here.
Yeah, no, it's great. Look, it's fantastic. It's always good to learn a little bit more about where the industry's going and what, get that inside scoop on the various manufacturers at shows like this. And because it's, like ISE and Infocom are really the only two shows where we all get together and can meet people like Justin, and because, I don't know, you don't really get out to Australia all that often.
I've never been. I'd like
There
to
you
go
go.
sometime, but I've never been.
Yeah. So we'll come to you.
Perfect.
Right.
It's a deal.
Yeah.
Excellent.
Sounds good.
Thanks, Justin.
Thanks, Mark.
Good on
Thank you,
mate.
Justin.
Pete.
Thanks, guys. Stay tuned for more exciting episodes of The Tech Effect from ISE 2020.
See you next time.
Bye.